Good day. My name is Louise Forbes and I'm an application engineer at Optimum Solutions. And today I'm going to be showing you how we can connect MATLAB to a PI server. Why would you want to use MATLAB? Well, MATLAB is a high-level language that is designed for engineers and scientists. It is professionally built and its ability to scale allows it to integrate into any workflow. This is the technical computing workflow composed of access, research, and sharing. For this webinar, we are going to be focusing on the access portion of it. When we talk about integrating with PI systems, there are three different ways we will cover in this webinar: using the OPC Toolbox, the Database Toolbox, and then CSV files. Let's examine how we would connect to a PI server using the OPC Toolbox and the PI OPC DA or HDA Server. The first thing we need to do is find all the servers on the computer. You can see here our server name is OSI Soft OPC DA2 DA1. We then need to create a DA object using this server name. We now have to connect to the DA server. The first thing we are going to look at doing is browsing the namespace interactively using the Browse Namespace function. This will open up a window that allows us to view all the different tags on the server. We can then move the tags that we are interested in to the right-hand side and load that into our workspace. You are also able to add tags programmatically. The first thing we are going to do is create a tag group using the add group function. We then are going to update the update rate to 20 seconds. Up here I have created a script of all the tags that I want to look at. These are all wind velocity tags for the 10 different wind turbines. I will then use the cell array to add the tags to the group that I have previously created. We can then pull the data from these tags using the read function. This will then appear in our workspace as a struct, and we can view the item ID, value, and other metadata associated with those tags. It is also important to disconnect from the server when you are finished. If we have a look at the features of the OPC Toolbox, the OPC Toolbox has UA and DA connection support. It allows for simultaneous data logging and numerical processing. Communication with OPC servers can be done using synchronous or asynchronous operations. If we consider the OPC UA connection in a simulation environment, here is a model of a steam turbine system composed of a plant and a controller. We've got OPC read and write blocks between these two components that will read the tag from the server. If we look at a short example of running this model, you will see that the tags are updated from the OPC UA server using these read and write blocks. We can then trip a switch in the simulation environment and see how the tags change from the OPC server. We can then also clear the trip and watch the resulting effects on the controller and the plant system. If we have a look at our second mode of integrating with PI systems, that of the Database Toolbox, we can use either the PI JDBC or PI ODBC driver to connect using MATLAB. In this example, we are using the Database Explorer app, which is an interactive environment for database exploration. The first thing we need to do is locate the correct catalog and schema that we're interested in. We can select the various tables and columns that we're interested in without having detailed knowledge of SQL. From my knowledge of these tables, I know that the element table has an element template ID column, and the element template attribute table also has an element template ID column. So what I'm going to do is, after I've selected the columns that I want, I can then perform a simple join operation in an interactive way using the element template ID column in both tables. I can then view what a preview of the data looks like, select how I would like to export the data. I can change the data name all from one environment. I can also choose how I want to import this, either as data, or generate the SQL query for my command, or generate a script so that I could later automate the process. You will see I have chosen to just import the data, and here is my data test in the MATLAB workspace. Using the Database Toolbox, you can explore your databases with either the Database Explorer app or a command line interface. To connect to a PI server, you will need the PI ODBC or JDBC driver and PI SQL DUS. If we have a look at our final way of integrating with the PI systems, that being with CSV files, we can either import this using the import tool or a command line interface. The import tool can be opened by double-clicking on a CSV file. From here, you'll be able to set the delimiter type, the range, the output type of the data, as well as what will happen to missing data. You can import just the data, generate a script, or generate a function to maybe automate the process and pull in more data. You will see that I have the data in the workspace, and now I can perform some simple data analytics. For example, changing the time vector and plotting the wind speed versus time. If we have a look at doing this from the command line, say for example you wanted to import all the data that was associated with the first turbine, that turbine called GE1. This script I have created will run through all the files that are GE1. And we've used the generate function to create an import file _ small table that will import all of files called GE1 into one struct. You can see there are 49 files that we are going to import. We've done this programmatically because this would take a significant amount of time if we had to do this by hand. You'll see we now have variables in our workspace, and we can then use this to perform data analytics. For example, viewing the actual versus set point values of blade 1 for the first wind turbine. So please speak to us at Optimum Solutions if you'd like to get started using a PI server or any other data analytics capabilities. We have technical support, consulting services, and training courses to ramp you up and get you started. Thank you.